I'm here with Pierre from Formlabs and Daniel from Axial3D. So in these first few minutes, if you just want to let us know if you can hear us well in the chat, if there's any technical issues, it's right now. So let us know if you can hear us good. And if you're experiencing any sound issues, you might want to switch to Google Chrome. But yeah, we're going to be starting in just a few seconds. It looks like everyone can hear us. Okay, great. So before jumping to the subject, we're going to ask you a few questions just to know why you're attending this webinar, and so that our speakers today can also, learn a bit more about who's attending, if you have any experience in medical 3D printing or 3D printing in general. So I'm going to pull up the questions right now. As you can see, we have 4 for you today, and you can just send in your vote. So the first one being, what is your experience of medical 3D printing? Do you currently own a 3D printer? What areas of medical 3D printing interest you the most? And then finally, what are your biggest drivers when it comes to planning for surgery? So yeah, I'm just going to leave these up on the screen for 1 minute. And if you could just let us know a bit more about why you are attending this webinar today. It's very interesting for our speakers and experts as well. So we have 22% who have voted already. I'm just going to wait a few more seconds to get some interesting figures. So for anyone joining, we are starting our webinar on the state of 3D printing in medicine, focusing on the benefits it can bring to surgeons and their patients. And I'm here with Pierre from Formlabs and Daniel from Axial3D. So just waiting for everyone to vote. I have put some questions on the screen, and you can let us know your experience of medical 3D printing, if you have any, and your experience of 3D printing. So just waiting a few more seconds. So again, this is just to have a bit more information on who's attending, if you have any experience of medical 3D printing, and why you're interested in this topic today. So just a bit. We have 70% who have answered. I'm just going to leave it on for 20 more seconds and then share the results with all of you. Okay, so it looks like actually it's pretty well distributed. So some people have some experience of medical 3D printing, some others don't. If almost 40% currently own a 3D printer. Again, pretty well distributed in terms of the medical 3D printing of interest. And then finally, it looks like most people, their biggest drivers is actually personalization. So thank you all for voting. Let's get right into the agenda for today. So as I was saying, we are going to be discussing today the current state of 3D printing in the medical sector, and more specifically, how these technologies can benefit surgeons and their patients. So I'm going to give you a very brief overview of the sector, and then Pierre Servaux from Formlabs will tell you more about the benefits of 3D printing in healthcare. So if you didn't know, Formlabs is a 3D printer manufacturer, expert in two 3D printing technologies, SLA and SLS, and they also provide high performance materials and 3D printing software. So then we're going to be discussing more specifically how 3D printing can lead to better patient care and improve surgical outcomes with Daniel from Axial3D. So Axial3D is an expert in medical 3D printing, and they aim to transform pre-operative planning and patient outcomes with 3D printing technologies. And then before jumping to the Q&A, we're going to have some time with Formlabs discussing the initiatives around COVID-19. It's true that during this health pandemic, it's really interesting to see how 3D printing companies can provide solutions very quickly for the medical sector. So we will be also discussing this with our speakers today. Speaking of speakers, so I'm here, as I was telling you, with Pierre Servaux, the Business Development Manager at Formlabs. So he helps the world's leading companies shape and implement their additive manufacturing strategies by offering ideation workshops, technical feasibility studies, and custom material selection. So with the support of Formlabs medical experts, Pierre is currently managing the company's projects surrounding COVID-19 in Europe. I'm also here with Daniel, founder and CSO of Axial3D. So Daniel founded Axial3D in 2015, following 7 years in the medical device industry. And he has an academic background in biomedical engineering, specializing in medical visualization and use of 3D printing in medicine. So under Daniel's strategic direction, Axial3D is focused on delivering groundbreaking software and services in medical 3D printing. And myself, I'm Carlotta from 3D Natives, editor-in-chief of the English market. So 3D Natives is an international online media platform about 3D printing. So we cover the latest news about 3D printing, but also offer decision-making tools about the technology. And we are also very present on events surrounding this technology, and we do webinars such as this one to talk to experts about the latest developments in additive manufacturing. So why is 3D printing used in healthcare? So it's interesting to pinpoint the benefits here of using this technology in healthcare. And one of the main benefits is that you can create custom-made and patient-specific medical applications. And this is key, as every patient, of course, is different, has different needs, has a different anatomy. So being able to create these custom-made devices is very beneficial for this sector, and is something that conventional manufacturing technologies can't really do. So of course then you have the other benefits of 3D printing, such as greater design freedom, speed and lower costs. And even though this 3D printing was maybe not thought of as a technology that could be reliable or mature enough a few years ago for this sector, it's true that in recent years it's matured, it's become more affordable and more efficient. So it can really deliver treatments and devices customized to serve each patient and their individual and unique needs. So this is the discussion we're going to be having with Formlabs and Axial3D today, going into more detail on those benefits and how healthcare professionals, such as surgeons, can adopt the technology for their activities and provide better patient outcomes. So the market is growing. I have here a figure from the Global Market Insights that predicts that the market will grow by 21.2% compound annual growth rate until 2024. So it's really showcasing that the more and more professionals are interested in the technology. It can bring many benefits to this sector. So in terms of applications, there's 4 main segments: customized prosthetics and orthotics and implants, 3D printed anatomical models for surgical planning and education, personalized medical equipment products, and then last but not least, and this is a bit different because it's relying on bioprinting technologies, it's tissue and organ fabrication, which is a field that is still, developing, and it's quite different to the other 3, but essentially creating layer by layer living tissue, and then maybe, in a decade or so, even 3D printed organs that could be used in human transplants. So those are the four main applications, and there are, of course, many technologies, many materials on the market. So Formlabs is going to discuss how their 3D printing solution works for the healthcare sector. And then we are going to be looking in more detail at the importance of creating 3D printed anatomical models for assessing different treatment pathways for patients to arrive at more successful patient outcomes. So I'm going to leave it with Pierre now to discuss Formlabs' solution for this market.
Thank you, Carlotta, for the introduction. So my name is Pierre Sarrault. I handle business development for Europe at Formlabs. And first off, I'd like to talk a bit more about who we are. So at Formlabs, we basically specialize in providing professional 3D printing systems from software to materials. We started off actually as a rather small company. It actually started in 2011 at the MIT Media Lab, and we launched a pretty successful Kickstarter campaign in 2012. The initial goal was to democratize SLA printing and make it accessible to everyone. Since then, we have grown a fair bit. We're now more than 600 people throughout the world, with 6 offices in all parts of the globe, 3 factories, more than 150 engineers, both in 3D printing with SLA and SLS, as well as material science. Since the start of the company, we've actually sold over 50,000 printers, and our printers have generated over 40 million parts, which makes us one of the leading companies in this sector. Now, while we've started with our aim to democratize SLA printing, we have developed our product portfolio quite extensively. Later this year, you'll see coming the Form 3L, which is 5 times the volume of our previous printers, as well as the Fuse 1, which is our first foray into SLS printing. We also have, of course, a whole selection of materials for various applications, including medical and the entire post-processing environment necessary for 3D printing. So I think one of the main questions people will ask in this webinar is why 3D printing and how can it benefit for medical applications? Now, as a whole, 3D printing actually transformed quite a lot of industries, not just medical, for the past few decades. Initially, 3D printing was essentially used for prototyping applications and product development. But since then, its usage has spread out to various other applications. In this particular case, what interests us is the production, the ability to produce on-demand, customized products. And now if you look at fields such as audiology and dental, 3D printing has become a main or mainstream production methodology, which is essential for this industry. So the value of 3D printing really lies, like Carlotta said earlier on, in the ability to produce unique tailored parts without the need for specific tooling to be created each time. And the technology allows for complex geometries while maintaining a cost from the first part to the 100th. So 3 of the medical applications we're mostly involved with at Formlabs is, first off, the development of medical devices and surgical tools. Also the production of orthotic and prosthetics, as well as we'll see a bit later on with Daniel, surgical planning models. When it comes to medical devices, actually 3D printing is invaluable because it allows very fast product development cycles. For example, recently a company called Neurology in the UK has managed to develop within a few weeks a rapid diagnostic system for COVID detection in the UK. And they've really relied on 3D printing to be able to do rapid iterations of their devices. When it comes to orthotic and prosthetics, 3D printing is more and more commonly used for the creation of orthotics insoles for example, diabetic patients. And when it comes to prosthetics, the fact that you can produce any shape, for example, modeled after a 3D scan of a patient's limb, make it invaluable in this type of application. Now, at Formlabs, we specialize mainly in one type of technology, which is called stereolithography, or SLA in short. I won't go into the details, I won't bore you with the technical details of how SLA works, but to make it brief, basically SLA relies on a UV laser to solidify a resin material. So what this does is that thanks to the very fine touch point of the laser, we're able to produce some of the most detailed prints out of any technology. As you can see on this print of a heart model, we're able to achieve very smooth surface qualities, as well as a high level of transparency, and replicate all the fine details that would be needed in most of our medical applications. So, given the importance of 3D printing in the medical field and in the dental field, we've actually come up with a printer that was optimized for this type of application, and it's called the Forms 3B, and is compatible with a range of materials that we have developed and that are biocompatible, meaning they can be used in contact with the skin, for example. So this is a printer that is really optimized for production with a large build volume for its size and consistent operation for continuous use. As a result, Formlabs is trusted by a lot of leading healthcare organizations that you'll be able to see in this following slide. Now, moving on, I'll let Daniel speak further in depth about his application, which revolves more about surgical models.
Thank you, Pierre. That was great. So my name is Dan Crawford, and I'm the founder and chief strategy officer here at Axial3D. And I just want to start off by saying thanks for 3D Natives for hosting us and for everybody who's joining us today. So today, what I really wanted to go through was just to cover a little bit of background on the company, Axial3D, and what we're doing in medicine, and give you a bit of an overview of the impact medical 3D printed models have on hospitals. So just a little bit on the company itself. We were founded in 2015, initially based in Ireland, but we've expanded our offerings globally, with our main R&D offices still here in Belfast, where I am, with our main commercial headquarters in Orlando, Florida. Our goal is, it's pretty simple. what we want to do as a company is create solutions to make it as simple as possible for hospitals to gain access to 3D printing. And to date, we've worked with hundreds of healthcare professionals across the world to actually help them get access to medical 3D printed models. And what I really want to talk about today is how the technology is being used in hospitals and how it's actually impacting on patient care. But first of all, I'll go through a little bit of the what's normal in hospitals. So as some of you may know, most surgery is actually evaluated on medical imaging scans like you see here. So X-ray, CT, MRI, and in some cases, three-dimensional representations. But all these have one thing in common. They're all visualized on a two-dimensional screen. So when it comes to really complex pieces of anatomy or very, very complex pathologies, it can be extremely hard to actually conceptualize and understand a very difficult pathology, even for the most experienced surgeon. So 3D printing's shown to have huge benefits actually over two-dimensional imaging, and there are papers dating back as early as the 1990s to show the technology's efficacy in medicine. And what I really want to go through are some real-world examples of how this technology is having a huge impact on surgeons and patients, and then really map this across the clinical journey that they go through within the hospital. But initially, for those of you who don't know the actual workflow for 3D printing and actually 3D printing anatomical models, I'll just touch on that. So at a very high level, there are three key steps in actually creating an anatomical model. First of all, there's the imaging acquisition and actually collection of the raw data, which in the majority of cases are DICOM images. So what we need to do is make sure that those DICOM images, usually CT or MRIs, are of high enough quality to create a 3D print like you see here on screen. And usually that is depicted by the slice spacing or density of the CT or MRI scan. Then following on from this, those images will go through a process the majority of people would call segmentation. So basically you're delineating or taking out the anatomy within those two-dimensional scans that you want to actually 3D print. So the segmentation is created and a 3D file is created from that. And then finally, the resulting mesh is then 3D printed. And as a company, we've been in this market for around 5 years now. And what I really wanted to show or share with you today is some of the data points that we've collected along the way on the clinical care pathway actually within the hospital, relating to planning, consent, all the way to improve surgical outcomes. And really, when it comes down to it, I suppose our most cited benefit with surgeons is to do with the planning itself, with almost half of users actually totally changing their plan when they look at a physical 3D printed model as opposed to actually just relying on the two-dimensional radiological images. And to back this up, there's a further 47% of users actually confirm their plan once they see the physical 3D printed model. So that's around 95% of users, in our case, surgeons and radiologists, are actually changing or reinforcing their plan when they get a 3D printed model, as opposed to just having a CT or MRI scan. One of the other huge benefits of anatomical models is in gaining patient consent. So we've carried out a number of studies around patient-centered benefits with hospitals like Barts in London, one of the largest neuro and trauma centers in Europe. And when they're using 3D printed models in their neurology departments for planning and patient consent, what they've recorded is around a 98% acceptance rate in patients, where they feel safer and better consented around their actual procedure or their surgery when compared to just using standardized imaging. And one of the other big benefits as well is reducing theatre time. So we have an estimation of around 62 minutes per surgery of a reduction in theatre time when a surgeon is actually using a 3D printed model to plan a surgical approach. And really what these reductions boil down to is allowing a surgeon to know exactly what equipment that they're going to use and bring into theatre. Allowing them to actually understand what they need to bring into theatre and reducing that amount of time has a series of knock-on benefits to the patient, whether that's reducing the amount of blood loss that a patient has to go through, the length of anesthesiology, or the actual chance of infection as a result of reducing that theatre time, which all goes towards reducing the actual overall cost for the hospital, which is great. So really, in summary, what these models actually do is to help avoid risk and allow surgeons to actually fully understand or conceptualize a patient's data and properly prepare for surgery, which then reduces the costs associated with surgery and times, but more importantly, actually improves the standard of care that hospital can actually give. So next, I want to take you through just some of the real world examples of what we see on pretty much a day-to-day basis now at Axial3D and where those models are used and what specialisms. So the first one that we've got here is in cardiology. So this was actually an 18-year-old adult male who had moved from Syria to the United Kingdom, who was presenting at hospital with extreme fatigue from just walking up and down the stairs. And when the patient went through the traditional imaging, what they found was this patient actually had a condition called double inlet left ventricle and pulmonary atresia. So the surgeon initially had approached us because he was trying to evaluate the patient's complex amorphous anatomy on hundreds of two-dimensional images. And he was finding it very, very difficult to actually conceptualize where the pathology was within the heart. So therefore, he couldn't actually properly prepare for the procedure. And what the 3D printed model of the patient's heart that was created from the CT angiograms give, it helped the surgeon actually perform an atrial septostomy. And the model was also critical in actually understanding where that pathology lay within the heart. So it allowed the surgeon to guide a catheter wire to resize a hole within the atrial septum and treat the patient, which drastically improved their standard of care. Next case I wanted to go through is in orthopedics. So this is a patient who presented with scoliosis, again, something that we see on a very regular basis here at Axial3D. So this patient was actually at the Royal Victoria Infirmary in Newcastle, where they actually have a Form 3 printer on site where we can remotely send them data to 3D print at the point of care. So when the surgeon approached us, given the amorphous, complex nature of the spine and the fact that he was evaluating that these 45 pieces of anatomy on hundreds of two-dimensional images, he was finding it very difficult to actually plan his approach and communicate his approach actually to the wider surgical team. So what we were able to do was take the two-dimensional images and reconstruct those into multiple iterations of the model that you see here. So he was able to use 4 models in total to do different shortening osteotomies on the spine. And that also allowed him to plan his approach and actually figure out exactly what equipment that he was going to need to bring in the theatre with him, which he estimated saved around 2 hours of surgical time. So the next case is actually one in neurology. And what this case really does is highlight the model's use as a consenting tool. So this is a patient who had presented at Tallahassee Memorial Healthcare in Florida. And after an angiogram, they'd actually found that the patient required a stent because of an enlargement of the carotid vessels within their neck. So really to understand the anatomy better and to really get a feel for the size and location of the aneurysms, the leading surgeon actually ordered a 3D print. And it was immediately obvious to that surgeon when he'd got the 3D print that it wasn't a typical aneurysm. It was one called a pseudoaneurysm. So this is where the actual vascular wall of the vessel had actually broken down and needed to be treated straight away using specialist equipment as opposed to a standardized stent that he was initially going to be using. So not only was he able to completely transform his approach from getting the 3D printed file, he was also able to use the 3D printed model that you see on screen here to explain to the actual patient the severity of the case and the time sensitivity of the case so that that patient could be properly consented and brought into theatre as quickly as possible. And the last case that I wanted to go through is really one that it kind of showcases the ability for a surgeon to really conceptualize very, very complex anatomy and create an accurate plan based on this new information. So this is a patient that I presented with a condition called hypothyroidism at the Royal Victoria Hospital, about 2 miles away from our main office. So this patient's thyroid gland in the neck had become oversized over time and was producing an abundance of calcium. So what that resulted in is the overcalcification or hardening of the patient's blood vessels, which eventually was leading to that patient going into renal failure and needing a kidney transplant. But unluckily for that patient, because the thyroid gland was continuing to produce calcium, they actually weren't eligible to be put on the transplant list, so it needed to be removed. So initially, the surgeon that you see here on the left, Mr. Brown, he'd gone in to the patient twice before to try to find the gland, but had been unable to actually find, locate, and remove the gland from the patient's neck. So what we were able to do was take the patient's MRI scans, create a 3D printed file that you see on screen here. And what that did, it really allowed the surgeon to get a better understanding of where the thyroid gland was in relation to the great vessels coming out of the heart, so the vena cava and the aorta. So this meant that when he went in again, there was no exploration in the surgery. He knew exactly where he was going to go and what piece of anatomy he was going to run up to actually remove the gland itself. So that was an operation that took 20 minutes, so a reduction of around 2 hours from the initial estimations from the anesthesiologist. And then following on from this, really happy to report that the surgeon was able to remove the gland and the patient's calcium levels have dropped. And that patient has since got a kidney transplant and has now got a full life expectancy. So hopefully that gives you a good overview of the uses of 3D printed anatomical models. And what we do as a company is really try to improve the access to the technology. With current solutions used in hospitals, they tend to be quite expensive or unscalable for a wide range of surgical needs. And this is mainly due to the segmentation bottleneck. And because of this, Axial3D has actually created an easy-to-use service solution that allows any hospital to really start and scale their 3D printing needs. So a surgeon or radiologist can securely transfer DICOM images through our cloud platform for processing. So we can process them on our cloud platform and post them out a physical 3D printed file. Or what we can also do is send those 3D printable files directly to a 3D printer that is actually on site. And this entire service that we've created is all underpinned by machine learning technology to remove the bottleneck of segmentation for hospitals all across the world and to make this technology ultimately as accessible as possible. where a hospital only requires an internet connection and a 3D printer to actually start their own lab. So that's really it from me for this part of the presentation. But before I move on to the next section of the presentation in relation to the coronavirus applications, I just want to say thanks to everyone for coming on and offer you a free medical model using our service, just to see what the service is like and also to see what a medical model looks like coming out of a Formlabs printer. And next, we're going to talk a little bit about some of the 3D printing use cases that are starting to help alleviate some of the bottlenecks in getting PPE equipment and surgical equipment out into hospitals. So internally, Axial3D has actually been printing a number of different devices, mainly actually face shields for hospitals. So we've printed thousands out using open source files to actually donate to NHS hospitals all around the UK. And what we've also been doing is creating a number of different component parts for things like respirators and ventilators to help alleviate those shortages in hospitals. And what I'll do is I'll now pass back on to Pierre to let him talk a little bit more in depth about these actual devices and what Formlabs are doing.
Thanks, Daniel. That was a really fascinating presentation. And I think Formlabs is proud to have partners like Axial3D in the medical field. So now I'm going to talk about our response related to the COVID-19 crisis. I'm going to share some information here, but all of it you'll be able to find on our dedicated webpage, basically formlabs.com/COVID-19 response. Now, before I move on, I just want to do a quick disclaimer, as I will be talking about medical devices, which are subject to regulatory approval and clearances. So I will invite everyone here and everyone using 3D printing to do so responsibly, and also want to remind you that we cannot guarantee that any product manufactured on our printers will be suitable for their intended purpose. So just a shorter, more human version of the disclaimer. Basically, currently we're facing a global pandemic and we're all in this together. So the situation is constantly changing and we're doing our best to help. So we really would like to thank you for your patience as we work with clinical partners, legal and regulatory bodies, as well as thousands of volunteers and numerous requests for help across the world. Now, for the efforts related to the COVID crisis, Formlabs is basically going through two routes, one clinical and one non-clinical. So the clinical route basically relates to all the parts that are used by healthcare professionals and patients, and as well as all the parts that are validated by medical professionals and authorities. Finally, it's usually parts that are manufactured in a control environment, meaning GMP, ISO 13485, or directly at hospitals. When it comes to the non-clinical route, we're talking about parts that are used for daily COVID prevention and that can be printed by the wider 3D printing community. So basically, a lot of people are wondering how they can help people that have 3D printers or people that don't have 3D printers but are still keen to hold out a lending hand. So on our side, we'd of course invite you to look at our webpage, and if you're a non-medical user, you can actually access our community parts library, which has a collection of items you can print that are non-medical items, but that can help in the response and alleviating the current shortages in the COVID crisis. If you're a medical device manufacturer or a hospital, you can actually contact directly your Formlabs point of contact reseller, or if you don't have one, just email us at covid-response@formlabs.com. Now, I'm going to talk a bit more about the clinical route, and there are 3 areas we have primarily focused on to this date. The first one being nasal test swabs, the second, ventilation system adapters, and the third one being mask and respirator components. So the first one, test kit swabs, is actually one of our most ambitious and impactful effort within this COVID crisis. We have basically undertaken in the USA the production of nasopharyngeal swabs for PCR testing through our 3D printing technology. So in case you're wondering what it looks like aside from the pictures, this one over here. So this is the USF design swab. So as you can see, it's quite flexible. And this is printed with our biocompatible resin called Surgical Guide. There are actually other models available. This one was designed in Spain. It's thinner and shorter, and slightly more flexible as well. So obviously we've undertaken the printing of the swabs to alleviate the shortages currently faced by a lot of countries in the world. Especially in the US, we've collaborated with the USF Health, which is the University of South Florida, as well as Northwell Health, to use their designs and supply 3D printed versions of the NP swabs. Ever since, we have started working with other companies throughout the world to address these shortages in other geographies. A second area of focus was virus adapters for respiratory systems. In this particular case, we're talking about converters to transform the more commonly available BiPAP and CPAP machines into ventilators that, again, a lot of hospitals are seeing shortages of, especially compared to the number of patients that they're intaking. Finally, our customers have also been very creative in transforming, in this case, snorkeling masks into respirators for medical professionals. So over here, you can see 2 examples, one in the US on the left side and one in Spain. So in both cases, they've been using Formlabs printers to create adapters to basically remove the top part of those snorkeling masks and fit filtration systems, medical grade filtration systems. So the one on the left is currently being evaluated by a leading hospital in Boston. And the one on the right is currently actually being used by several Spanish hospitals. We are seeing several similar initiatives ongoing right now in various parts of the world as well. So on the non-medical side, so on the non-clinical route, we have come up with the Formlabs COVID Community Library, which is a global initiative. So the reason for the creation of this library is that we've invited our community to register to offer, either to ask for help in the supply of COVID-19 related medical parts, or to offer their help if they had a 3D printer at their disposal, and if they had some bandwidth to create new parts. What we have found is that we had a very good response. Thousands of people offered their help through this portal. And we also discovered that actually a large number of those people were not medical professionals. And so we wanted to find a way so that these thousands of people could actually provide their help within this crisis while remaining, I would say, on the safe side when it comes to regulatory concerns. So Formlabs, we have curated a library of non-medical COVID-19 devices that are ready to be used on a Formlabs printer. We have sourced these designs for various contributors such as Bellis 3D, the Yale School of Medicine, Materialize, as well as our broader Formlabs community. So a few noteworthy examples is that you have face mask fitters that will basically improve the fit of your mask onto your face. We have door handles, which allow you to open doors without touching directly the handle with your hands. as well as face mask clips and buckles to improve the fit of protection masks. So if you are interested in contributing and printing for your local community, please feel free to visit this website and you'll get access to those files. Now, I think the time has come for Q&A. So before I leave it, hand it over, I really like to thank all of you for attending this webinar. And I hope you're all in good health and remain so.
Great. Thank you, Pierre. It was really interesting learning about Formlabs' initiatives around COVID-19. We did get a few questions throughout the webinar, so I'll just be asking some that I picked up on the chat. So the first one to Daniel, how is the business model of Axial3D? How does it work? Is it a license for the hospitals, or do you charge per part produced? So
yeah, that's
more of a business question, but
yeah. No, it's a great question. Well, we're relatively flexible in how we produce the models for different hospitals. Whether you're a research hospital and you're getting a research grant, we'd usually sell a package. But the majority of hospitals that we work with will do a pay-per-click model, whereby they're only paying for what they use, and they generally find that a lot easier to get through hurdles like procurement.
Okay, and we also had a few questions about the price. So one of them, can you give us an idea of the price of one small model for a hospital, including the price of the software to process the images, create the model, and print it?
Yeah, well, the pricing would vary depending on the size and volume of a model and what the imaging modality would be, and it also depends on the volumes that a hospital would actually be producing every year. But we'd be more than happy to share that with whoever asked the question and get them a pricing proposal for their specific site.
Yeah, actually, a few people were wondering the studies that you put up on the presentation and the case studies. They were asking where they can find that information again and have more details on the results you shared.
Yeah, we actually there's a number of those studies that are on our website under the case study section, and I think our marketing manager Ryan Kyle is on the webinar as well, so he might be able to put a link to that on the chat. And if there are any others that you want more detail on, please feel free to reach out to us, and we'd be more than happy to share those results.
Okay, great. And for Pierre, we had quite a specific question. I don't know if you'll have an insight on this. What materials developments relating to soft tissue-like properties is currently emerging for SLA printers, if you have an idea on this? But it's quite specific.
But when it comes to material development, I mean, I can say that Formlabs are actually constantly developing new materials for biocompatible and non-biocompatible applications. But unless we have an NDA with that particular person, I can't really tell more about it, unfortunately. So it's an area for us, but I cannot divulge ongoing material development efforts.
And today we focused mainly on SLA, but a lot of people are asking SLA versus FDM. You know, what's the main difference here for the medical sector? Why go for an SLA solution over an FDM solution?
Well, both technologies, to be honest, have their pros and cons. There's no perfect technology. I mean, I think SLA and FDM are very complementary technologies. In the sense that SLA will usually perform better in terms of detail restitution. So as we've seen the example of anatomical models, a lot of them would be difficult to produce with FDM, given the precision requirements and the detail restitution needs in order to have an effective anatomical model. FDM parts may be more robust in some long-term usage applications. However, it really is on a case-by-case basis. There are other technologies as well when it comes to 3D printing that are used in the medical field, such as metal 3D printing for implants and other medical devices. But when it comes to SLA, it's really all about if you need to have a true-to-form print or a precisely fitting, in the case of prosthetics, print, then the added precision and surface finish will go a long way in that matter. To help that.
Okay. And we also had a few questions about the more generally the trends. Are they the same? Are we seeing the same developments everywhere around the world, in the US, in Europe, in Asia? Is it a uniform trend of adopting 3D printing for the medical sector, or not? Do you have any insights on that?
Well, traditionally, the US has a tendency to lead the trends at this level. And I would say maybe American companies may be a bit more adventurous in trying out new technologies. However, Europe and Asia Pacific are really not far behind. So, as you can see with Axial3D, we have very innovative companies in the region that are pushing these new applications to the market. And I think the reception so far has been quite good.
Yeah, we had a specific question for Daniel. Intentions to expand operations to South Africa, someone asked.
So we actually, we partner with a number of different labs across the world. And actually we, as of, it was February this year, we have partnered with a 3D printing lab based out of South Africa, just outside of Cape Town. So we do the same model that we use for our US healthcare providers, whereby all of our segmentation and model processing is done on the cloud in region, and then the actual models are printed and distributed in South Africa.
Okay.
So we have a partnership there, and we'd be more than happy to connect with whoever asked that question to see if we might be able to help them out.
Yeah, and someone asked if you could explain in more detail, and again, the segmentation process, actually.
Yeah, of course. So I suppose the segmentation process, it kind of answers another one of the questions of, what is the biggest bottleneck at the moment that's stopping medical models being used in hospitals all around the world? And it's really that. It's quite a lengthy process, and it requires a very specific skill set. So really what it is it's annotating or drawing on hundreds of two-dimensional images to pull out or delineate the anatomy that you would want from those 2D images. They're then reconstructed into a 3D model, which can then be post-processed into a 3D printable file. But for an engineer to do that, it might be 2 or 3 hours of processing time. But really, what Axial3D are doing is automating that process. So taking something that takes 2 or 3 hours for a surgeon or an engineer or radiologist to do, and breaking that down into minutes.
Okay, and actually the 3D printed anatomical models, someone asked if it would apply for the dental sector as well, or not.
I suppose, Pierre, do you want to take that? I think Formlabs has a quite comprehensive presence in dentistry.
Yes, actually, well, we do. And the dental market is actually very important nowadays, and is constantly growing. So for the dental industry, 3D printing as far as uses such as printing models, such as the creation of dental aligners or even surgical guides. So I would say that the dental market now is even more established than the broader medical market, and that the applications have been very well defined.
Okay, great. I don't know if you have anything else you wanted to touch on in the last 5 minutes, but I think we're pretty much ready to wrap this up. Again, all the case studies, as Daniel mentioned, you can find them on Axial3D's website, because we had a lot of questions actually on asking for more specific details on those studies, from the material used to checking the figures again. So it'll be interesting for people who joined this webinar to be able to find those case studies. And I don't know if you have any more words from your side.
No, I don't think so from me.
Sorry. And ended up speaking at the same time.
Yeah.
Go ahead, Daniel.
No, I was just going to say, no, I don't think there's anything from my end. I just want to thank you for organising this, and thanks for everybody in joining. And if you have any other questions or more detailed questions, please feel free to reach out to me or the team via our website.
So we will also share, because I can see that people are asking if they will be able to see these slides again, but we will share a replay of this webinar on 3D Natives. So you'll be able to check everything that was shared on here today again. So thank you again to Pierre from Formlabs and Daniel from Axial3D. Thank you for joining us and for discussing, the benefits of 3D printing for the medical sector and how it can create better patient outcomes. So thank you. And see you soon.
Thank you to everyone. And just a quick word, I've put some questions in the chat that haven't been answered. So if you have any questions about Formlabs, we're quite reactive. Feel free to reach out to us. You have all our contact details on our website, and someone will get in touch with you. But thank you to all the attendees, and thank you to 3D Natives for organizing this webinar. And thank you very much to Axial3D. It's a pleasure to work with you guys.
Thanks, Pierre. Thanks, everybody.
Pierre. Thank you. Okay.